Welcome to this video lecture series on data structure and algorithms. Today we'll be learning about linear and non-linear data structure. So let us start with what is a data structure? Well, data structure is a logical way to store and organize data so that it can be used efficiently. In computer science, a data structure may be selected or designed to store data for the purpose of working on it with various algorithms. Data structure can mainly be divided in two types, the first one being linear data structure and the second one is non-linear data structure. So let's have a detailed look on both of these data structure. Starting with linear data structure. The data structure where data items are organized sequentially and they are attached one after another is called a linear data structure. Data elements in a linear data structure are traversed one after the other and only one element can be directly reached while traversing. All the data items in linear data structure can be traversed in single run. Examples of such linear data structures are array, stack, queue, and linked list. Let's again explain all these linear data structures, starting with array. An array is a collection of data types of similar type. In this diagram, we can see an array of 10 elements with indexes starting from 0 to 9. So let's say we have this real life example as we have to store 10 roll numbers of various students in a class. So instead of storing all the roll numbers separately in an integer variable, what we do, we create an array of integers and store the various roll numbers corresponding to each of the indexes of the array. So this let us to save a lot of memories. Next comes the stack. Well, stack is a last in first out data structure where the data added last is removed first. The addition to the stack is called push operation and removal of data element from the stack is called pop operation. In this diagram here, let's take an example of a school bus. Suppose there are these 5 seats in a school bus. So the very first student who will be riding the bus will have to take the seat at the last. And the second one will take the second last seat, and just like that, the fifth student or the last student will have the first seat. Now when the bus reaches its destination, the student who will be coming out from the bus at the very beginning will be the fifth student, that is the student who rode the bus at the end. And like this, the first student who rode the bus will be coming out at last from the bus. Next comes queue data structure, which is a first in first out data structure where data added first is removed first. There are two special terms related to queue data structure. One is back or rear end of the queue and another is front end of the queue. Addition of any data element in the queue happens at the rear end and this operation is called enqueue, and removal of any data element from the queue occurs at the front end and the operation is called dequeue. Let's take an example of a queue of students who are waiting for the lunch to be served. So the very first student who stands at the first of the queue, that is at the front end of the queue, will get the lunch first and will be removed from the queue. And the next student will be inserted into the queue from the rear end of the queue, and this way the students will get their lunch. The last type of linear data structure we will be considering here is linked list. Linked list is a collection of nodes where each node is made up of a data element and a reference to the next node in sequence. Now if we take the same example of storing various roll numbers of various students, we can do this same thing. Instead of having an array, we can have this linked list. We can sometimes face some memory constraints when we use array. So we can use a linked list instead, and also here we can store different types of data. For linked list, each of the nodes have two different fields. One is the data field or value field, another one is the pointer to the next node. The first node of the linked list is called the head node, and the last node of the linked list has this special characteristic that the pointer field of the last node will point to null pointer. Now let's have a look at the non-linear data structure. The data structure where data items are not organized sequentially is called non-linear data structure. A data element of the non-linear data structure could be connected to more than one element to reflect a special relationship among them. Here, all the data items cannot be traversed in single run. Examples of such non-linear data structures are a tree and graph. Now let's have a bit of explanation on this two different data structures, tree and graph. So tree is a data structure that is made up of a set of linked nodes. This particular data structure emulates a hierarchical structure and form a parent-child relationship. We can see in this diagram there are various nodes A, B, C, D, E, F, H. This A node is called the root node of the tree. B and C are the child nodes of A, D is the child node of B, E and F are the child nodes of C, and H at last is the child node of D. Now if we have to take an example, let's take this example of various employees in office. All the employees have different posts, like managers, officers, typist, clerk. So if we want to store all these data about the employees and also want to store it in a way so that the hierarchy of the post can be indicated properly, we can take this example of tree. So this node A represents the manager, B and C represents the officers, D, E and F represent the typists, and H represents the clerk. Next comes graph data structure. A graph is a collection of finite number of vertices and edges that connect the vertices. Edges represents a relationship among vertices that stores the data elements. In this diagram, we can see a simple graph where we can see 5 nodes 0, 1, 2, 3 and 4. Let's take an example and explain how this graph data structure gives us the reflexibility to store the data and define a particular relationships among those data elements. Suppose there are various classrooms in a school building and they have this particular relationship that if a teacher takes a class in a particular classroom and there are many other classrooms which are connected to that particular classroom, then that teacher will have to take classes in all those connected classrooms. Let's simplify it. Suppose teacher A takes a class in node 0. So now as node 1 and node 4 are connected with 0, so the teacher A will also take his classes in node 1 and node 4. Same, if teacher B takes a class in node 1, then as 0, 4, 3 and 2 nodes are connected with node 1, hence the teacher B will also take his classes at node 0, node 4, node 3 and node 2. Lastly, let us have a look at the differences between linear data structure and non-linear data structure. For linear data structure, due to their linear or sequential organization, they are very easy to implement in computer memory, whereas due to the non-linear organization, it is very difficult to implement non-linear data structure as the computer memory itself is linear. The data items in linear data structure can be traversed in single run, whereas it cannot be done for the case of non-linear data structure. Thirdly, each item of linear data structure is attached to its previous and next items, but each item is attached with many other items for the case of non-linear data structure. We will conclude this video by saying that whenever we have a certain set of data and we need to operate some works on those data, we first have to consider what kind of data we are working on, the relationship between them, and the way we should be storing those data in order to get our work done easily. Considering all these cases, we can then choose to go for either linear data structure or non-linear data structure. Thank you for watching this video and staying with us. See you next time.